Why did Schrödinger's cat take up programming? Because it heard about the open-closed principle and wanted to be both open and closed at the same time. Never mind. Join me in unraveling this apparent paradox in today's episode of Codesday. You surely know that the open-closed principle is one of the 5 solid principles stated by Robert Martin, aka Uncle Bob. However, the principle first appeared in Betrand Meyer's book in 1997 called Object-Oriented Software Construction, the 2nd edition. If you haven't read it, or even worse, you haven't heard of it, make sure you sell a kidney and get it. Kidneys are overrated anyway. Betrand Meyer's definition of the open-closed principle sounds as follows, and I'm going to quote here. The first part states that a module is said to be open if it's still available for extension. For example, it should be possible to expand its set of operations and add fields to its data structures. And the second part states that a module is said to be closed if it's available for use by other modules. At the implementation level, closure for a module also implies that you may compile it, perhaps even distribute it in a library, and make it available for others to use. Let's look at an example situation that Betrand Meyer uses to describe the application of the principle. For instance, imagine we've got module A, which contains functionality that modules B and C and D are already dependent on and are using. Imagine now that module X comes along and it also needs functionality which we have in module A. Now, without object-oriented techniques, he says that the only 2 options would be to either change the existing code in module A, thus potentially breaking the existing clients, or by effectively copying the code into another module, A', and make the changes in there. The latter approach has the downside that, extrapolated in time, it would lead to an explosion of variants, many of them very similar, although never identical. However, using the 1997 new object-oriented method of inheritance, we'll arrive at a very elegant solution, he says. All we have to do is to create another module A' that inherits from module A and use this new module inside of module X. Now, this is a tricky argument to make. It kind of implies that the developers of module A need to somehow have some sort of prescience to know in advance what to mark as inheritable, because if they don't, then either they make everything inheritable and potentially overridable, which is madness, or they don't make anything inheritable, which makes the module not open for extension, which is kind of bad. This is where Uncle Bob comes into scene. 5 years later, in 2002, he takes this principle and rewords it a bit, and together with some examples, manages to clear up the muddy waters left behind by Betrand Meyer. In his book, titled Agile Software Development, Principles, Patterns, and Practices, Uncle Bob states the open-closed principle like this. Open for extension. This means that the behavior of the module can be extended. As the requirements of the application change, we are able to extend the module with new behaviors that satisfy those changes. In other words, we are able to change what the module is doing. And closed for modification, extending the behavior of a module does not result in changes to the source or binary code of the module. Let's illustrate Uncle Bob's definition of the open-closed principle with a small diagram. So in his book, he says, let's imagine we have a client class that directly uses another class called server. Now, this design obviously breaks the open-closed principle, since in order to change the server implementation, we need to change the code in the client class. Because the module that hosts the client class has to be recompiled, the downstream clients of that module have to recompile, and those clients, and so on. A better approach that satisfies the open-closed principle is to put an abstraction between the client and the server so that the client class is only dependent on the contract, and any further implementation of the server that respects the contract will be able to be substituted as a dependency for the client. And this would look something like this. So instead of the client being dependent directly on the server class, we'll make it dependent on an abstraction called client interface, and we'll make the server class implement that interface. And in terms of modules, these two will sit in module A, and this one would sit in module B. He continues to say that he named the abstraction client interface instead of perhaps abstract server because, and I quote, abstract classes are more closely associated to their clients than to the classes that implement them. It means that whatever methods are defined on that interface, they are there to serve and represent the client's needed behavior. I take that to mean that the client and the client interface live in the same module, whereas the server implementation lives potentially in a different module. This whole thing implies that if we apply the open-closed principle to module A, we cannot change what the module does, since that is represented in the client interface. Yet we can change how it does it, because only the stuff in module B is free to change and implement the interface. Meanwhile, module A is open only for extension, not modification. So if we can change the contract, how can we change what the client does? The contract is the only part that specifies what the client does with its dependencies, whereas the concrete implementations describe how the client works. I have one more remark before we move on to the coding part. Again, most related to the terminology used. I just want you to be aware of it when you will be reading Uncle Bob's book. He mentions a lot the fact that he uses abstract classes as abstractions. Even the client interface he gave as an example is implemented as an abstract class. You have to understand the context in the book. Most examples in the book are in C++, so it makes sense he uses terminology that is related to that language. In C++, there are no interfaces per se like we have in C#. C++ supports multiple class inheritance, which C# does not, so there is no need for explicit interfaces as such. You can express an abstraction through an abstract class. Moreover, in C++, a class is not explicitly declared abstract like in C#. A class becomes abstract automatically if it contains at least one abstract method. The C++ terminology for an abstract method is a pure virtual method. In C++, an abstract class can be considered the equivalent of a C# interface if all of its methods are pure virtual, abstract in C# parlance. So what I want you to understand, what I want to highlight is that just because you will read the term abstract class when reading the book, that is not the same thing when you apply the open-closed principle in C#. And one more general note, just because two domains use the same term does not imply that it represents the same concept in both of them. With that said, let's look at a coding example, because after all, today is Codesday. Enough theory, let's get some coding done. This will be less like a tutorial and more like a live coding session, so it's gonna take a while. Feel free to grab your popcorn and enjoy. All right, enough chit-chat, let's get some coding done. Well, let me tell you the story. So, your customer comes to you and says, I would like my application now to send emails because 21st century. So you go and you write some code like this. You take the email and you send it through SMTP. Well, the client says, yeah, that's cool, that's lovely. However, Mondays are really special and we need to send them with carrier pigeons. So you go and say, okay, fine. If Mondays are so special to you, let me write some new code. You get the current day of the week and you say, if current day is Monday, send with carrier pigeons, otherwise with SMTP. Okay. The client comes and says, yeah, you know what? That's lovely. However, Tuesdays are even more special and we need to send email with magic carpets. And you say, fine, okay, I can do that. And you write this code. And I can't even spell. So if it's Tuesday, send with magic carpets, otherwise send with SMTP and so on. And he does this to you for every day of the week, month, year. And you end up with something like this. Okay? Now, what seems to be the problem? Well, the problem is that, like you've just seen, you need to come in here and change the existing code to support new ways of sending email, right? So each time a new request comes in, a new requirement comes in, you have to change the existing code, right? And this breaks the open-closed principle. This class or this method should be able to be extended with new behavior without changing its actual source code. Let's see if we can do that. Well, first of all, we'll need to start off testing this thing, right? Because remember from the previous video, we said, okay, first of all, before you even start touching the code, refactor or otherwise, you have to write at least a test to pin down the functionality, okay? So, because here we don't have any test of any kind, I'll just create a new project in here, a test project, let's call it tests very creatively. Oh, already exists. Okay, never mind. Let's call it email tests, because why not? All right, and I'll put this over here. We'll make this word wrap. Okay, let's make some room for ourselves. And what can we do? How can we test this thing? Well, first and foremost, let's rename a few things. Ooh, by the way, let me start my key press visualizer so you see what I'm pressing here in case you want to follow along. Test one, yes, that's lovely. Okay, cool. So the actual code we can write for now, it's almost something like in here. Okay, we have to inject the reference, fine. So, okay, but then what? This method has no return type, right? It returns void. So there's no output value to test. So how do we go about this? Well, in a very interesting way, actually. First of all, let me, because I've got, sure. I've got GitHub Copilot in here running, so we should be able to get some AI assistance. And let's see if we can ask Copilot to do a trick for us. What I want to do is, you see, right now, this thing is like hard-coded to write to the console. Okay, I've got this write line here, which I can do because I have this global usings file in here, which basically injects the system console as a static using case thingy. So it's a neat trick in C#. Instead of having to do this, I can automatically write line because I'm doing a static injection of the console dependency. Anyway, the point is, this thing is hard-coded to write at the console. So without changing code, right? Because we want to test the thing before we actually touch even a single comma in the code, a single dot in the code. We want to be able to test this thing. So how can we do that? Let's ask Copilot redirect console output to string. Really? Is that all you can do? Okay. Sounds about right. Okay, I've got some code over here, obviously from Stack Overflow. That's what all good programmers do, copy code from Stack Overflow. And indeed, we have to create a new string writer, set the out of the console to this writer, do our thing, then flush and read the string back. Let's see. So we did the first part, okay? So we redirected console to a string writer. Technically, I should be putting this into a using statement, but since this is only going to live just inside this method, it almost doesn't matter, but okay, let's be politically correct. So once we write to our console, calling our send email static method for now, let's just say, well, I'm gonna call this writer because it's more appropriate, and I'm gonna need the output variable in a second. So we want to do writer.flush, and then writer.getStringBuilder to string. Okay, cool. Yeah, I could do that. However, if you remember from our previous video, I want to install one. I need just one for now. And assertions. This is a cool little package. I'm going to demonstrate to you or go into detail about it in another video, but for now, just take my word for it. And this thing allows us to write something like this. Okay, import. And I can do the same thing in here. Extract global using. Yes, please. So I don't have to see the usings in here. It's up to you, but hey, I'm just showing you all kinds of stuff. All right, so let's see what happens. So if we run this test now, I'm going to make this visible up here. Oh, it's going to fail, obviously, because today is Tuesday, as it happens. So it should send emails with magic carpets, not with SMTP or whatever. So what I have to do is take the code from here and replace SMTP with magic carpets. And now if we run this, it should pass. Unexpected white space at the end. Really? Whatever do you mean? Really? TDD by putting breakpoints. Let's see, maybe I skipped a step or something. Okay. Okay, I know what's happening. Right. He does have a point. Trim, because write line. So after we print the string to the console, technically write line appends a new line character, return carriage and the new line. Well, there's two characters, but hey. So, all right. Now if we run this, it should pass. Cool. So we did a trick. We diverted the console output. Instead of going to the actual console, we placed it in a string in memory so that we have something to test against. Okay, so yes, this is weird, this is funky, but this was the only thing we could do in this particular situation. I'm not saying it works in any situation, but hey, if you've got a console application which writes to the console, you can redirect the output and test the output like this. Okay, cool. Hey, it's better than nothing, right? Now, where are we at? Well, we just managed to test one of the scenarios. Why? Because we've got this hard-coded thing in here, okay? So because this method and this class are hard-coded, are strongly connected to the system datetime current date thing, okay? We are bound, so there is no way for us to influence what date the code chooses, so there's no way to influence it at test time, okay? And we would like to do that, and we will in a second. Now, remember, our goal is to prove or fix this code to respect the open-closed principle. In the meantime, we're going to see we're also going to fix it to respect the single responsibility principle, but that's a side effect. Yeah, just to know what we're looking for here. Okay, right. What we need is a way to... Ooh, let me show you something interesting. I'm going to go off on a tangent here. And by the way, this is going to take a long time, okay? It's going to be a long video, just saying. So strap onto your seats. It's going to get bumpy. Cool. What I want to show you is that test code is still code. Just because this test passes doesn't mean we're done with it. Okay? It doesn't mean it's done. Because later on, you're going to want to come and see what this test is doing. And hopefully it has a nice descriptive title, like, okay, we're testing the output of the method and blah, blah, and so on. But even so, even with the descriptive title, if you look at the code, this looks like a mess. I'm creating a string writer, console set out, flush, all this kind of weird stuff. I don't want to see this. This is not part of my test. This is not what I'm testing. This is just instrumental stuff that I need to do, coincidental complexity that I need to add in order to test my method. I don't want to see this in my test, okay? Remember, tests are still your code. Code has to be cleaned up. Code has to be refactored and made tidy and really understandable and maintainable. This is not, okay? So let's see what we can do about it. Well, the whole point of this thing is like, here I'm setting up the environment, right? I'm redirecting the console output. Here I'm reading from that redirected output, and then I'm testing. So the only two parts that I actually want to see in my test are this thing and this thing, right? This is the test, okay? If I'm calling send email, then I get this output back. That's all I want to know. How can we abstract this away, okay? How can we make this invisible, or visible only if you want to look at it, okay? Let's see. So I want to do, if you look at this thing, I could take all this stuff and extract a method from it. Okay, let's call it output, doesn't matter. And what you can see here is if you squint your eyes, inline variable, I don't like that. What varies in this code in here? Just this line, right? Which is an action, or actually it's a function. Well, no, it's an action because it doesn't return anything. Sorry, my bad. So couldn't we, let's see if Rider is smart enough. Introduce variable, no. Okay, I'm going to write it by hand, okay? So, by the way, if we run this test, it still runs, okay? It still passes. No harm done, okay? Cool. Let me hide this. Okay. So, what we want to do is to be able to receive an action. Action, no, it's not null. You give me an action. There's no null for me. I'll invoke it for you. Hopefully this thing will affect the console somehow, write to the console somehow, and we're gonna be able to catch that, okay? So if I take this from here now and put it in here, and I think I can even do this. I can't? No, I can't. Okay, cool, cool. Never mind. It's fine. Okay. Okay, let's give this a more meaningful. So capture console output. Ta-da! How about that? So I have a utility function here, right? To which I pass an action which does something with the console. I capture that console output. I give it back outside to the test, and then I'm testing it. That's all I need to know. That's all my test should be doing. Cool, cool. Now, let's see what we can do with this bad boy. Because right now, this is the only thing that's stopping us, that's preventing us from testing the other scenarios. Because right now, we're at the mercy of this daytime now, day of week. This won't change until tomorrow. So if we don't allow ourselves a way to inject this piece of information into the code, there's no way for us to control what happens to the code. There's no way to test this, okay? We're gonna be at the mercy of the code, so we don't want that. Okay, cool. Let's see what we can do about this. Technically, I can do something really funky. And I'm not gonna say you should do this always, just whenever you can. Hear me out. Let me, because I don't want to change the staticness of this method yet, if I can help it. How about we extract a method? Now day of week. Yes, really creative. Current day of week. Even more creative. Oh well. Okay. Cool. However, if we leave it like this, there's no way for us yet to inject anything. Ooh, by the way, let's see if this thing still works. It should. Yeah, it does. Okay, cool. It's good to test your tests once in a while, to exercise your tests, okay? Now, what I want to do is... Ooh, yeah. And I see where I'm going to go with this, but since I told you I'm going to do it, I'm going to do it and tell you why that's bad. Okay, let's make this public. And extract a class. Let's see. Current day provider. Sure, why not? Sounds funky. Okay. And where I wanted to go with this, well, obviously nothing changes so far. However, if I create a constructor for this, and I'm going to pass in my preferred day of week, right? And store that. I hope I can do this. Okay. Ah, no underscores. I hate that. Some people love it. I hate it. That's fine. We're all different. Static constructor must be parameterless. This isn't going well. I thought I could inject a day of week. Okay, never mind. No constructor, no cry. Fine. Public static. Set current day of week. Why not? What don't you like? Empty static constructor. This is not a constructor. Or is it? Let's see. What's wrong with you? Method must have a return type. Sure. Here you go. Void. Cool. And instead of I'm going to paste this in here. I'm going to overwrite it. And then I'm going to return the current day of the week. This is funky. Funky in a bad way. We'll see in a second why. What? Okay, fine. So if we run this now, it should still pass because we haven't done anything with that thing yet. So it's still giving us the current datetime, the system datetime, right? Populated by this guy. However, what we want to do is to inject it, right? So if I could do something like this. Ooh, and I didn't even realize it. See? Set current day of week, get current day of week. I didn't plan for this. Okay, let's say it's Monday. So if we run this now, expected magic carpets. No. Oh yeah, expected magic carpets, duh. But got carrier pigeons. Ooh, lovely. And this is the worst thing you could do. And I'm going to tell you why. Well, because we've created a dependency on these two static classes, which is not apparent in any way unless you read the code, and even then it might not be obvious. But definitely in the calling code, there is no way to know or to understand that there's a relationship between this guy and this guy. It's totally bonkers, okay? Don't do that. I did this so I can show you what not to do, okay? Okay, never mind. So what we want to change now, what we want to do is to turn this current day provider thingy into a proper dependency, make the email sender class not static so we can inject explicitly a dependency so we can see the relationship at runtime or at test time or whenever you write the code, okay? Because this is bad, this is really bad. However, even like this, if I change the test just for the fun of it and run it, it should pass. But you don't want to do that. Okay. Let's see. Okay, cool. So what can we do? Well, first of all, we would like to okay, let's try and start with this one. Make it non-static. Introduce variable current day provider. Fine. We would like to be able to make a new instance out of it. Obviously, we cannot yet. So if I do this and this, okay, almost there. Now if we run it, okay, it works, but obviously we're still not there. We haven't actually solved anything because the dependency between these two guys is still not visible. We have no idea this guy uses this guy. Okay, maybe this guy is not static anymore, but so what, right? That doesn't tell you much. Okay, now, can be made static. No, it was static. That's exactly what I don't want. Okay, now, if I were to just take out the static modifiers in here, this code would break. And I don't want to do that. Well, actually, remember, we've got a passing test, okay? So it's okay to change code, to refactor code, as long as all your tests, in this case one, still pass, okay? So we're not changing anything yet. What I want to do is, just like we did in the, instead of, we changed the non-staticness of this class, of the current day provider, and in order to use the set method, now we also want to change the get method, and because of this, it's going to force us to make this whole thing non-static. Okay, let's see how. I introduce a variable, just like in their current day provider. Okay, let's create a new instance in here. And all we gotta do is make this non-static. Let's see. Run. And it works. But here's an interesting thing. The field remains static. Now, that means we can create as many instances of this thing as we want all over the place. But if we set the current day and we get the current day, where all of us, we're gonna modify the same location in memory, that's not good, because we're using static variables as a means of coupling in pieces of code which are not obviously coupled. Okay, and that's bad. That's really bad. Okay, don't do that. Okay. So what can we do? I'm just taking off the static of the field as well. So this instance and this instance are going to have their own day of week thingy. Well, that doesn't take us very far and doesn't solve much. Ooh. Exactly. So, here's what happened. This guy is making a new current day instance of current day provider. No one's setting the current date for this guy. The test does it, but the code doesn't. And maybe I shouldn't have done that yet. Let's see. Okay, cool, fair enough. Leave it like this for now. Let's just make sure our test pass again. And it does. And let's see how we can fix this thing. Well, the whole point was to be able to inject an instance of this thing. So instead of creating it here in the send email method, let's take this outside. Introduce field initializer. Yes, thank you very much. Next. Why'd you name it like that? Okay, much better. However, static constructor. Okay, we're getting there. Can be made read-only. I don't want to do it make it read-only just yet. However, remember, I can't move assignment to initializer. No, that's where we came from. I wanted to put it as a parameter for this guy. Okay, never mind that for a second. Let's just see. Hey, we made a step in the right direction. Let's just make sure our test pass again. And current day provider. Okay, obviously we want to make this non-static so we can inject through a constructor, because I don't want to inject it through the method, because it's not really the method's responsibility. Well, I know it is. I mean, it's calling it and stuff, but I feel this injection should sit at constructor level. I guess it's just a preference. I'm not sure exactly. I don't have enough arguments for this right now, but it kind of feels right. We'll see where this takes us, and we'll explore in a second. So what we want to do, again, start refactoring the tests first and then the code. Introduce variable, right. Again, new thing. Let's do the right thing. So this is not static anymore. This is public. Send email is not static. This field is not static. Okay. Let's see if the tests pass. No, it doesn't. Wait a minute. What? Oh, I'm sorry. We don't need that right there. Oh, come on. Okay, build. Okay, build successful. Okay, the test now passes with our email sender no longer static. Okay, now what we can do is because read-only. And now what I'm going to do, this is interesting. Why does it do that? Oh, come on. Oh, I'm stupid. Introduce parameter. That's what I wanted to do. Current day provider. Bam. Okay. This can be made read-only. Okay, fine. So what we managed to do is to inject, okay, but I don't want to do this. Hey, use my thing. Because I already got one. Okay, it thought I wanted to initialize it outside and just move the code out there. But I already had an instance of my own. So let's see. If we run the test, it should pass. And it does. Okay, cool. So where are we at? Now, we are able to inject from outside a dependency which gives us the current day of the week. Therefore, now we can presumably test all these test cases in here, right? This thing can be made static. No, oh, by the way, let's see. Can we do this now? Yes, we can. Lovely. Okay. Nice. Ooh, another thing I want to highlight. So, see, this class doesn't have an interface. This email sender thing is just depending directly on this class. Ooh, spooky. Well, not so spooky because the whole point of this class is to be a utility class that gives us the current day of the week, and sometimes it allows us to inject it. So yeah, not that big of a deal. I mean, I wouldn't put an interface just yet on this dependency just for this reason. Okay, obviously I can fake it very well, thank you very much. Otherwise, I have to put an interface on it, create mocks, and all kinds of complications. And I don't need that right now. Okay, obviously it works as it is. Why make the design more complicated than it needs to be? If we find that this thing is used in 10,000 places and potentially with different implementations, okay, maybe slap an interface on it, but we don't need it just yet. So hey, Yagni, you ain't gonna need it. Wait until you do. Okay? All right. Now, I said we want and are able to test different scenarios. So now we're testing with Monday. Let's see what would happen if we were to test with, I don't know, Tuesday. But how should we go about that? I wouldn't want to write another test, right? Because this would be almost identical, okay? All I need to do is change here Tuesday and say here magic carpets. And unit tests, run everything. Yeah, it works fine, but man, it's a lot of code for nothing. How about we do something smarter instead? XUnit is a funny little library that allows you to write facts, right? Like this one, which is just a thing, one thing. On the other hand, it allows us to write something called a theory, into which we're able to inject at test time multiple, let's call it data points, and run the same test with different outputs and expecting different different inputs and expecting different outputs without having to write the extra code? Allow me to demonstrate. So the first thing we have to do is turn this fact into a theory. Well, don't read too much into the must have test data. Yes. Just a second, Mr. XUnit. Oh my God, and Copilot shines. Oh, I love this tool. So, now that we have inline data, now that we have data points to inject into our test at test time, we need to alter the signature of the test method to have parameters. So it should have as many parameters, obviously, and of the same type, as the things we're trying to inject. So in this scenario, we need a day of week, creatively named day of week, and a string called expected output, because why not? And it says they're not used. Well, duh. And if we put here the date of week, and if we put here, but I'm not going to put the whole thing in here. I'm just gonna put this thing, and I'm going to change this to expected transport. Okay, so how are we transporting this email? With carrier pigeons, fine. The hello thingy is gonna come from us. And so I put the day of week here. That's done, okay? Let's change this bit over here. Introduce a variable, email body. Okay. This doesn't matter almost. I mean, it could be a random string, which is an interesting idea. Maybe we'll explore it later, but for now, don't read too much into it. It can be this, okay? It doesn't matter. Okay, maybe it can't be just that. Quite that thing. Email body. And in here, instead of hard coding carrier pigeons, I'm going to put the expected transport. Now, we've got a theory with one use case. That's almost a fact. But let's see if this works, because if it doesn't, we've got bigger issues. Luckily, it works. And underneath the test one thing in here, which until now it was just this, test one. Now we start to see use cases popping up, okay? And this is interesting because I'm going to put some more in here. Let's see if GitHub Copilot knows what I want to write. Yes, that's right. And another one. Yes. And another one. I swear I haven't staged this. This is for real. Oh God, I love AI. And that's it. That is it. Technically, we could do a thing. Yeah, you know what? I'm gonna do it in a second, but let's see if all these tests pass now. And I'm saying tests because although we only have one test, we're calling it with multiple inputs and expecting multiple outputs, and it works. How cool is that? Okay. So we managed to test all our hard-coded test cases, okay? So this is right in the console. Okay, we managed to divert the console. This was getting the current day of the week from the system. Well, not anymore, because hey, we're smart. All right. I said we're gonna do one more. Let's see if this works. Because technically in C#, Let's see if this works. In C#, we've got these funky things called enums. And enums are actually just labels slapped onto integers. So, hey, integer 0, we're going to call it Sunday. Okay, fine. However, you can forcibly cast an int to an enum, although that int is not in the original definition of the enum. So let me see if this... So what I want to do is force day 8 to be a day of the week. And I'm going to hit this scenario. So technically, we should see SMTP in here. But just to make sure this thing doesn't just pass, because if I run it now, okay, let's run it, Let's run it. And it works with day 8 of the week, whatever that is. However, what I wanted to say is, first, you have in TDD, the cycle is red, green, refactor. And you have to make it red. You have to make it red so that you know the test fails for the reasons you think it should fail. And then when you fix the reason, the test passes for the reasons it should pass. So for now, everything just passes. Everything's peachy. But is it passing for the right reasons? Or this thing didn't have any impact on it? So let's mess it up on purpose. Let's run this thing again. And it says, expected SMTP, I got SMTP X. Ooh, okay, fine. Red, green, and maybe refactor. Well, not maybe, refactor it. Except in this case, we've got nothing much to do. So now we put in place a harness that makes sure that our function, our method, with the least amount of modifications necessary, still works as before. So now we've got a solid foundation where we can start we can start focusing on the open-closed principle. Until now, we just injected dependencies and made the thing testable. Okay, cool. Let's see what we mean by that. Now, what was the original problem with this thing? I mean, from the perspective of the open-closed principle. And that problem still persists. We haven't done anything to fix that problem. If in the future we get new conditions under which we need to send email with different transport mode or whatever, okay? It's not the days of the week, they're the days of the month or days of the year, whatever criteria, doesn't matter. We will need to come in here and change this stuff. And that's bad, okay? Because we risk messing up the scenario for Tuesday when we're fixing the scenario for Monday, or any combination thereof, or all kinds of weird stuff. Plus, even if we don't break anything, the assembly that this class sits in will need to be recompiled, potentially with a new version. All the dependencies of this assembly will need to be recompiled, potentially with new versions, and so on. Okay? So what can we do? What's the strategy here? What do we want to do? The whole point, I mean, why this method is bad fundamentally is not that it's using a switch case statement, okay? Is that it's doing two things. Again, single responsibility principle. Well, it has 3 responsibilities at least, but hey, first of all, it knows how to get the discriminant, okay? What should I base my decision on? Then it knows to make that decision, how to make the decision. Ooh, if Monday, then do this. If Tuesday, then do that. And the third thing is it actually acts upon that decision, I'm doing a console write line to which I'm sending the string sending email with carrier pigeons. Okay, so it's doing at least 3 things. Let's fix that. Okay, so let's put this aside for a second. Even this now kind of gets in the way. And I don't need to do this. Well, either I do it here or I take it outside. It's still performed once during one test. So, I wonder. Let me try something. I'm going to make a constructor in here. Take this outside and introduce field. Okay, cool. So I want this to be set up once, because in XUnit, unlike any other testing frameworks, the constructor of the test class is invoked once per test. So if I had more test methods in this test class, I would get the constructor executed invoked for each test method. I'm not sure exactly here in the theory. I mean, does this count as a new test? Or, actually, this is interesting to see, and we're going to test it now. It's not going to affect the overall quality of the test or what the test does. It's just a thing to clean up the test code a bit in here. And I can also extract this, because as long as I've got a reference injected into the email sender, I don't need to do that every time. And, sorry, not parameter, introduce field. I don't know why it wants to put that 1 at the end. Let's format this. This can be a lambda expression. Okay, much better. This is exactly what we want to do. Arrange act assert. Ta-da! Clean as a whistle. How did I manage to do that? I don't know. Anyway. Now let's run this. And I'm curious, is it going to invoke the constructor every time it does an inline data for a theory, or... So I'm just going to debug it. Okay. Just run. Ah, okay. So this is going to be created for it. So it interprets each inline data as a new test. Okay, hey, it did that anyway. I mean, even if I left everything in here, it would still be executed each time we ran the test anyway. So it almost doesn't matter. But it's cleaner. We exported unrelated test stuff outside of the test. Hence, our test is cleaner and easier to read. Okay, what does this test do? Well, setting up the email body, injecting the current day of the week, sending an email, and then checking the output. That's it. I mean, it cannot get simpler than this, I hope. Anyway, comment down below. Okay, cool. Back to our open-closed thingy. All right. So, what did Uncle Bob say related to the open-closed principle? So now we've got a class or a method, send email, which is using or doing stuff itself, right? Writing the console in this case. How could we change the architecture of this code so that whenever a new way of sending email comes along, we are able to just add that to our architecture, to our code, and not change this class? Well, let's see. Well, first and foremost, let me try something. So I'm going to extract a method, and I'm going to call it simply send. And we're going to see in a second why. Because if you remember from last time, I want to do this trick. Ooh, and let me, because Rider has a bug. I've already logged it with JetBrains, and I think it's in triage, whatever that means, at the time of the recording. So if your constructor is in Lambda form and you want to extract a method into a class, so you want to do extract class, it doesn't work. Okay, deep down inside it logs a null exception. Okay, object not sent to an inferent instance of an object or whatever, that thing. So I have to change it explicitly into a curly brace thing format, and then our extract class thing will work. And here, carrier pigeons email sender. Bam. Okay. So instead of us writing directly to the console, I say us, the method. Instead of the method writing directly to the console, now it's calling another dependency, which it creates itself for now. Okay. But we're going to change this in a second or in a minute, because this is going to take a while. So feel free to skip ahead, because I'm going to do this thing over here. And I'm going to do the same thing for all of these methods. So and the last one, the most boring one. Okay. And we ended up with this mess. Wow. Okay. Cool. Well, not so cool, but anyway. What's the problem with this thing? The problem is that if we look at all these classes, if we squint really hard, what we can see is they've got almost the same signature. They have the same method called send with the same argument, doing almost the same thing. So wouldn't it be nice if we could like extract this commonality into something common, like an interface? So if we were to extract this interface, we would be able to treat them abstractly. Our send email thing won't have to deal with the various classes, various concrete classes, instances of things to send the actual email. So it will just say, hey, someone with this contract, I'm able to talk to it. And if I tell it to send email, it will send it. I don't have to care. I don't have to know who it actually is. Okay, so cool. Let's see what we can do. So I'm going to extract interface I email sender, right? And all I have to do is come in here and do this. Okay, so what? Now we've got interfaces on all these classes, but we're still constructing them ourselves? Well, almost. Watch this. So, we're gonna do a thing. Instead of creating the sender in here, I'm going to inline field. Okay, so we got rid of it from up here from the constructor where the previous refactoring placed it. And I brought it in here inline, okay? Because I want to do a thing. I want to introduce a local variable. And I want to call it email sender. And that's it. But this is going to be of the type of the interface. And I can do that because, hey, we just implemented an interface. Let's do this same thing. Well, actually, you know what? I'm going to... Not field. Why doesn't it know split? Split and move variable declaration to outer scope. Outer scope being out of the scope of this switch statement. Okay, cool. So we've got this global variable in here. Yeah, move declaration closer to usage. No thanks. I'm going to instantiate or initialize it by default. Well, actually, no, because that would be a waste of memory. I wanted to initialize it by default with the new instance of SMTP email sender, but obviously the current day is going to vary, and we're going to have in memory initialized one SMTP sender and another proper sender for the current day. So you don't want to do that. Don't initialize stuff that you know it's going to be initialized later. Don't waste memory. Don't make the garbage collector work more than it has to. Okay, so let's see if we actually need to do that, because right now it doesn't complain about it. So what can we do then is, if you can imagine, if we're going to do the same thing for all these cases, we don't need to actually send the email right here. And we can take this outside. Okay, now it's going to complain because it's not initialized, because it doesn't know you have this thing in here. But bear with me a second. Let's just leave it like that for a second. Let's inline the field and introduce variable. But now I'm going to delete this var thingy, and I'm going to call this thing the same, email sender. And again, cut this away. Inline field. Introduce variable, no var, email sender. Thank you very much. Bye-bye. Inline field. Introduce variable, email sender. Goodbye. Inline field, variable, email sender. Bye-bye. Bye. Inline field, variable, sender by, and inline field, whoops, variable, email sender by. Ooh, interesting. Okay. See, it doesn't complain now anymore because it understands that no matter what, we're gonna come out of the switch statement with the email sender variable instantiated, initialized, so there is no way we can wiggle ourselves out of this. And we can convert this to a switch expression, which is much more nice and tidy. Okay, let's format this. Cool. So what we managed, let me collapse this for a second, just so. So what we managed is to place each email sending strategy or transport, right, in its own class behind the same interface. And now our email sender class is no longer dependent on concrete transport classes. It's only dependent on this abstraction, email sender. It doesn't know who is going to do the sending in that day, but it knows for sure it has a method called send, which it can call. That's all it needs to know. Now, what we can see if we squint again is something, by the way, let's see if our tests still pass, because it's been a while since we exercised them. Oh, they still pass. Wow, what a surprise. Okay. Let's see. What is this method doing now? It's calling a dependency to get the current day of the week. Then it does some low-level magic to determine, because of this day, I need to send email this way. And then it calls another dependency to send the actual email. Doesn't that seem odd to you? Like, high level, I'm calling a dependency, I'm doing my own thing. High level, I'm calling a dependency. Right? A method should operate at the same logical level of abstraction. So high level, low level, high level. That's bad. Okay. So what can we do? Yeah, what can we do? Extract the method. Email sender. Let's call it get daily email sender. Or okay, not much has changed, except for the fact that, remember the trick? Extract a class. Oh, by the way, how's my constructor looking? Nope, this is not cool. Oh, just to prove it to you. Extract class, and I'm going to say email sender factory. Next. Bam, nothing happened. And if you look into the writer's error log files, you're going to see an error in there. So I have to change this from a lambda constructor to a curly brace constructor. I don't know what the term is for that. And now if we try to do the same thing again, we're going to call this a factory because that's what it is. You give it some inputs, so some raw materials, such as the current day of the week, and it's going to give you back an instance of an email sender, right? So hey, it's a factory. Bam, now it worked, okay? So again, we have this thing in here, which, let's format the code a bit. Ooh, by the way, if you notice down there, I'm pressing Control-E, Control-F to format the code. So these are I think the default shortcuts, but hey, you can set up your own. And I'm going to show you, I'm going to create a different video for tips and tricks with working with Rider, and also the tools I'm using, the fluent assertions thing, the mock library that you've seen in the previous video. And yeah, we're going to talk much more in depth about those things, but later. Right now, let's see. Do we want to depend on this? Ooh, first of all, I can inline variable and make this a body expression, because these are cute. So as long as you give me the proper ingredients, namely the current day, I'm going to give you an instance of an email sender. Cool. Peachy. Do we need to abstract this away? I would say no for now. And we can make this static, I guess. Make this static. Make this... sorry. We can make it static because reasons. No, I don't want to create a new instance. Hence, I'm going to... Oops, not abstract. Jesus, what? Make it static. Yes, please. Okay. Why? Because, at least for now, until somebody else comes in and needs this kind of functionality, there's no reason for us to put this behind an interface or even inject it or whatever. It's a utilitarian class. Like you see, it has no state, right? It doesn't have private fields, it doesn't have properties, getters, setters, and all that stuff. All it has, it's one method to which if you give it the right ingredients, it knows by itself, without help from outside or whatever, to arrive at the proper result, okay? So this behaves more like a utilitarian function, like a link extension almost. So even if we accept the definition of Betrand Meyer's open-closed principle. So we've got this module, this assembly, into which we've got this static class. Somebody else wants to reuse this functionality in here. Well, reuse it as it is, because this is basically a dictionary. If Monday, then this sender. If Tuesday, then this sender. That's all it is. Okay? It doesn't have logic. It doesn't have an algorithm that you can improve or whatever. It's just that, a dictionary almost. Okay, and it could actually be implemented as a dictionary inside, but regardless if we change or not the implementation to use a dictionary, for instance, that doesn't matter very much, because everything that everyone cares about is, hey, you have this nice method that if I give the current day to, I get the email sender. That's all I care about. Okay, so for now, I would suggest to just leave it like this. Yes, it's a static dependency, so what? Okay. The thing with static dependencies is that they're not visible. And obviously you can't mock this and you can't inject it from outside. So if you look at the test is, yes, I depend on a current day provider thing, but there is no factory that I can see you depend on. So I could presume that you are not doing this piece. But then again, you don't know what I'm doing. You shouldn't know what I'm doing. That's the whole point with objects. You don't have to know how I'm doing stuff. Okay? You need to know what I'm doing. I'm sending an email, sure, but you don't need to know how I'm doing that. So until proven guilty, I would leave this as is for now. Okay? Just saying. So if we run our tests now, they still pass. Let's give this theory a cute name, because why not? Oh my God! Emails are sent with the correct transport. God, I love AI. Okay, cool. Thank you, Mr. Robot. Okay, so I would say that we managed to achieve our objective. Like now this thing obeys the open-closed principle, I would say. Because if tomorrow we decide that the week has 8 days and we want to send with somehow else, all we have to do is create another class using the same interface, implementing the same interface. Come in here and change this, true, but its only reason to change is to change the dictionary. Like, hey, if the 8th day of the week, then send emails like this. And there's an interesting aspect to this, and I'm gonna get to it in a second. But for now, we will need to change this, and we wouldn't even need to touch this, because again, we get the current day of the week, we call the factory dictionary thing, we get the new instance, whatever that is, and we just call it and send the email. So from this point of view, from the point of view of open-closed principle, this class and this method are done and dusted. Okay, we'll never have to touch it again, as long as all that's changing in our application is the way we transport, the way we send emails. If something else happens and we have to introduce some other kind of business logic, like even though it's Monday, you have to override or even though you're getting this email sender, you have to override it or whatever. So open-closed principle is a strategic pattern. You have to apply it strategically. You cannot be open-closed for any modifications that might come into the future. You're only open-closed. It's like a shield. It's directional. It protects you from these kinds of changes. But if you get requirements coming from this direction, you've got no shield there. And you either put another one in there or you switch this one because this direction is more important than this direction. So open-closed, you cannot protect yourself from anything just by applying this magic bullet open-closed principle. Okay, it's not a magic bullet. It's just a pattern. Okay, just a principle. Okay, so leaving this aside for a second, let's come back to this interesting thing. Right now, what we have here is almost like a dictionary, right? And it's hard-coded in code, like, hey, if Monday, then instantiate this thing. If Tuesday, this thing, okay? Like I said, if tomorrow, or in the future, we get the 8th day of the week or whatever, okay? We'll have to come in here and change or add this new switch case, right? This new scenario. But there's something else we can do. And this thing only works in this particular scenario. So as long as the criteria for determining which email sender to send with, okay, remains like this simple and trivial, okay, like the day of the week, you can imagine we can take this outside of the code, put it in some sort of configuration file, JSON or whatever, declare in there, if Monday, then this type of instance, and using the activator, right, the activator capability in C#, okay, we'll create at runtime dynamically an instance of that particular type and just run with it. And this works as long as you can keep the criteria, the definition, the condition onto which to base your decision what email sender to instantiate. You can keep it in a serializable form, like in a text form, in a config file of some sort. So if you can do it, if you can do that, then everything's peachy. And let me just, I'm not going to do it for all of them. Let me just imagine we would read some sort of Let's imagine we read some sort of configuration thing from here. Let's make another string. Email sender type. And I'm just going to write it because obviously in a configuration file you don't have access to reflection, all that stuff. So we're gonna, I think the type is gonna be so carrier pigeons email sender from inbox, I think. Then we get this thing. Okay, so we're using the activator. Yeah, okay. Not in here, but in here. Ah, no. Type get type. No, create instance. I don't think that's... String assembly name, string type name. Assembly name and type name. Okay, presumably you can put these two pieces of information in your configuration thing somewhere. And box. Let's see if this works. Okay, let's... we don't need that. And going to replace this with this email sender thingy. Let's run the tests, because if the tests pass... Ooh, they crashed. Okay. Unable to cast object of time system. Object dot unwrap. Okay. I think this changed. Oh, okay, cool, works. So you see, so the tests have passed. So if you could get your definition, your dictionary thing somehow from outside, even this class would boil down to, okay, I'm going to read the daily string, okay, the string of the day. I'm going to create an instance dynamically through reflection, and all I have to do is, I don't even care about the current day. You give me the condition, okay? You tell me, or no, sorry, you still have to get the current day. With this current day thing, you match it, you match the the information you read from configuration, and then from the information you get from configuration, you create dynamically an instance of this guy. And that's it. You externalized the dictionary. The dictionary is no longer hard-coded in code. It's somewhere in configuration. As long as you've got the code and you can change the configuration, you can basically swap these things at runtime however you want. So even this thing is going to become open-closed, right? All it does is read from configuration. Okay, you change the configuration, but you don't change the code. You don't have to recompile. Okay? That's the catch. If you made it this far, you're superheroes. If you found any of it remotely interesting, feel free to comment down below and perhaps even subscribing. So, thank you very much and see you on the next episode of Codesday.